Hello students, let us discuss metals, nonmetals and metalloids in the modern periodic table. As we discussed in the modern periodic table, the elements are classified in four blocks, that is S block, P block, D block and F block. But there is another broad classification of element, that is elements are classified as metals, nonmetals and metalloids. In the periodic table, metals, nonmetals and metalloids are classified in this way. In the periodic table, you can see which is shaded with red color, they are the metals, and which is shaded with blue color, that is nonmetals. And in between the metals and non-metals, we can see a zigzag line or zigzag area which represent what? That is metalloids. From this, it is clear that the metals comprise more than 78% of known elements, and they appear on the left hand side of the modern periodic table, and the non-metals they appears on the right hand side of the modern periodic table, and in between there are some elements which show both the metallic and non-metallic property. That means in between the two metals and non-metals there are metalloids. So let us discuss more about metals, non-metals and metalloids and the periodic trends in the properties of these elements. So let's first discuss about metals. You are quite familiar with the metals. Metals are solid at room temperature except mercury, which is liquid at room temperature. You are familiar with mercury, which is present in a thermometer, that is liquid in nature. But the known examples of metals like brass, that is actually an alloy. Then we have copper, aluminium. These all are the examples of metals which you can appear in the solid state in the room temperature. Metals are malleable. They can be beaten into thin sheets. This can be used for making the different shapes in the different vehicles and in the different parts of the body of aircraft, etc. So these are the property of metals are called as malleable. Metals are even lustrous. Lustrous means they have shiny appearance. Because of this reason only, the metals like gold, silver, platinum, etc. are used in the case of jewelry. They are used for making jewelry. Even the metals can conduct current, electricity. When we take gold, we can see it also conduct electricity like chromium, titanium. So these metals conduct electricity and they are malleable. That means when they are beaten, it will be converted into thin sheets. When we take an aluminium foil, so in that also we can see that it conducts electricity. They are shiny. The important physical properties of metal which we have learned, that is metals are ductile, malleable, good conductor of electricity, good conductor of heat. They have shiny, therefore that property is called as lustrous. They have high melting point and boiling point. They have high density and have strength. So these are the important physical properties of metal. Examples of metals, that is copper, which you can see in the electrical wires, the copper is present in that, lead, tin, nickel, aluminium, zinc. Metals plays a very important role in the industrial field. Next, nonmetals. Nonmetals, let us discuss its properties. Nonmetals have low boiling and melting point. They aren't sonorous, that means they does not produce a ringing sound. Nonmetals are, some are solid in nature like carbon, phosphorus, sulfur, selenium, iodine. Even they does not conduct electricity, even though they are shining, but they does not conduct electricity. Even it is not malleable, it is broken down into the pieces, that is called as brittle nature. So the important properties of nonmetals are soft except diamond. Diamond is a form of a carbon and carbon is a nonmetal. So diamond are hard, but other all nonmetals are soft. They are brittle, that means break easily. Dull, not shiny. They are the insulators because they does not conduct electricity. Exception, graphite. Graphite is a form of a carbon which can conduct electricity. They are mostly colored gases. They are odor and with pungent smell. So these are the important properties of nonmetals. Examples of nonmetal that are oxygen, nitrogen, hydrogen. These are the nonmetals which is gases in state, and there are some nonmetals which is solid in state in the room temperature, that are sulfur, carbon, phosphorus, selenium, etc. So these are the different examples of nonmetals which are familiar to you. Let us find out the position of some element in the periodic table, whether they are metal or non-metal. Like osmium, find out where is osmium here. It is on the left hand side, therefore it is a metal. Iodine, iodine is on the right hand side of the zigzag line, therefore it is a non-metal. The element like yttrium, it is on the left hand side of the zigzag line, therefore it is a metal, which is also shining. Phosphorus, phosphorus is on the right hand side, therefore it is a non-metal, which is also a non-conductor. In the modern periodic table, we can find out there are some zigzag lines which are actually the elements like example silicon, germanium, arsenic, antimony, tellurium. These are the bordering line that is actually run diagonally across the periodic table. These shows properties that are characteristic of both metals and non-metals. So these elements which show both the metallic and non-metallic property, or we can say that is in between the metals and non-metals, are called as metalloids, or they are also called as semi-metals. Semi means half. That means they are partially metal and partially non-metals. Let us discuss its properties. Let us take the example of silicon. Silicon is shiny, but it is not malleable. When it is connected to the circuit, it is found that the bulb glows, but less in compared to the metals. So we can say that they are in between metals and non-metals, called as semiconductors. These zigzag lines are called as elements, semi-metals, which separate the metals from non-metals in the modern periodic table. properties of metalloids. The elements are classified as metalloids, have a physical properties of both metals and nonmetals. They can be a shiny, some are dull, some are malleable and ductile. Semiconductors have heat and electricity conductors, but their conductivity is lesser than the metals. Example, that is silicon, germanium, arsenic, etc. So in this video, we have compared metals and non-metals, their properties. Let us distinguish metals and non-metals. That is, depending upon the properties, metals can be distinguished with non-metals. With appearance, we can see metals are shiny, non-metals are dull. Hardness, they are very hard. Metals are very hard, but exception, some metals are soft like alkali metals, which can be cut with the help of a knife. Non-metals are brittle. Metals are malleable. Non-metals are non-malleable. Metals are ductile. Non-metals are non-ductile. They are the good conductor of electricity and heat, but they are the bad conductors. Usually metals are in the solid state. Non-metals are existing in the solid, liquid and even in the gaseous state. The density of metals are higher and the density of non-metal is lower. So these are the properties of metals and non-metals from which we can distinguish these. So we learned about metals and non-metals in this video, and let us discuss its metallic property in periodic table. In the modern periodic table, when we look at this one, the metallic character actually decreases when we go from left to right. That means the metals which is usually exist on the left hand side, they are the metals, and on the right hand side there are non-metals, and in between them there are metalloids. So we can say that when we move from left to right, we can say that the metallic characters go on decreases, but the metallic character increases when we move from top to bottom in a group. That means when you compare the metallic character of beryllium, magnesium, calcium, strontium, barium, radium, we can say that top to bottom the metallic character increases. So that is a periodic trend in the property of metallic character in the modern periodic table. That means metallic character increases from top to bottom and the metallic character decreases when we move from left to right in the modern periodic table. So this is all about the metallic character, non-metallic character and metalloids, which we have discussed in this video. And we also discussed that the metallic character in the periodic table, the elements are arranged in which we can say that when we move from top to bottom, the metallic character is increasing in the elements, and when move from left to right, the metallic character is decreases. So the periodic table is arranged in such a way that we can characterize, or we can say we can compare the characteristic of the elements, that is their metallic character, we can compare it. So that is all about this video which we have discussed about metals, non-metals and metalloids. So have a nice day.